Hey there, I wanted to go over solving using the quadratic formula. Remember, we're going to just be solving quadratic equations, and they do need to be in standard form, and they do need to be set equal to 0 before we solve them. And of course, we're using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So as long as we have the equation in standard form and then equal to 0, just go ahead and look at the a, b, and c values. So of course a is 3 and b is negative 5 and c is negative 2. So the values always just are the numbers, never the variables, and then of course make sure you have your signs with you. From there, it's really just about plugging in and simplifying. So x equals, so we're going to take the opposite of b, which is negative 5, and plus or minus the square root of b squared, which is negative 5 still, minus 4 times a, which is 3, and then times c, which is negative 2. And all that's going to be another radical, and then all of this is going to be over 2 times a, which is 3. So usually what I end up doing is I start to simplify this. Just look at these easy parts here first, negative, negative 5, and then 2 times 3, so those parts are easy to simplify. So we get positive 5 plus or minus, and then of course 6 on the bottom. Then we got to start where the work really is inside the radical. So take a little bit more time there. So we're going to take negative 5 and square that. Of course, remember, squares are always positive, and negative times a negative is always positive. So negative 5 squared is positive 25. And then as I look at the next 3 numbers here, I'm going to think about that as a negative 4. So I have a negative here and a negative here. So it's 2 negatives. So I know my result over here is going to be positive. And then I worry about what the numbers are. So now I'm ignoring those signs. 4 times 3 times 2, 12 times 2, which is 24. Don't lose your x equals, so we still have 5 plus or minus the square root, so 25 plus 24 is 49, all over 6. And then the square root of 49 is 7, so 5 plus or minus 7 all over 6. And so here's where we start to deal with that plus or minus. So essentially the problem is going to split into 2. So why we use that plus or minus symbol for is to indicate that we're doing both adding and subtracting of these numbers, just kind of a shorthand. So we're going to do 5 plus 7, and that's going to be divided by 6, and then we're also going to do 5 minus 7, and divide that by 6. So of course we get 12 divided by 6, which is 2, and here we get negative 2 divided by 6, which is negative 1/3. So those are our 2 values for x, 2 and negative 1/3. So this problem could have been solved using factoring. This problem is factorable. If you take a times c, you get negative 6, and factors of negative 6 that add to be negative 5 would be negative 6 and 1. So this problem is factorable using the AC method. We could also fast solve it using the completing the square method, but I'm just showing you that it is also solvable this method. So let's try another example. This one will be a little bit messier as far as the way the answers look. So that last problem, we had 5 plus 7 here, so we're able to do that. So here we have x squared minus 4x plus 7 equals 2x. So remember, we want the equation to be in standard form and also be equal to 0. Since this 2x is over here, I want to make sure I move that to the other side. So go and subtract it. So x squared minus 6x plus 7 equals 0. So now a is 1, and b is negative 6, and c is 7. So x equals the opposite of b, which was negative 6, plus or minus the square root of b squared, so negative 6 squared minus 4 times a, which is 1, times c, which is 7. All that's under your radical, and then all of that's over 2 times a, which is 1. So as I start to simplify, I'm going to look here. So double negative, so we got positive 6 again. And then on the bottom, the 2 times the 1 is just going to be a 2. Then I can focus more energy on the inside where there's more work to do. So negative 6 squared is 36, positive 36. And as I look at these, I have 1 negative and then 2 positives. So that's going to be a negative product. And 4 times 1 times 7 is 28. So x is going to be equal to 6 plus or minus square root of 36 minus 28 is 8 over 2. You know, while you're doing all this, you may be tempted to divide and things like that. You really should not do this, anything with the denominator, until the very last step of this process for any problem. So that worrying about that too is the very last thing I want to do. So last time we had the square root of 49 here, which was a perfect square, and 8 is not a perfect square, so we can't square root that in the normal way. So what instead we're going to do is sock 8 out, see what the square root of 8 is equal to. So 2 times 4 and 2 times 2. So we got you know, a pair of 2's, and then we have our lonely 2. So our buddy's going to go outside, and lonely guys are going to stay inside. So we got 6 plus or minus, so that buddy of 2 gives me 1 2 on the outside, and that lonely 2 gives me the other 2 on the inside. So the square root of 8 is equal to 2 times the square root of 2. And that's all over 2. So now as we look at the top, so with 6 plus radical 2, or 2 radical 2, we can't do that math. So we can say we want to do it, but we can't do it. So that's as far as simplifying as I can go on the numerator here. So we're done simplifying. So now what we want to do is look at reducing. And as long as these 3 numbers here have something in common, I'm going to ignore this. As long as these 3 numbers here have something in common, I can reduce that. And of course, these are all divisible by 2. So just like reducing a fraction. So 6 divided by 2 is 3, and then plus or minus. And then this 2 divided by 2 is 1, so I have 1 radical 2, so I'm just going to write radical 2. And then, of course, this 2 divided by 2 is 1. And so, you know, I could put a 1 there, but, you know, we usually don't do that. The same way, there could be a 1 right here, but we don't do that. You know, right here, but we don't do that. And so there's the simplified answers. And so, you know, you could just say, you know, here's x, where x is. Or if you want to see it as 2 separate numbers, it would be x equals 3 plus radical 2 and x equals 3 minus radical 2. You know, the square root of 2 is about 1.4, so this would be about equal to 4.4, and this would be about 1.6, like far as just, you know, trying to think about like what these numbers are equal to. So either way, though, you write your answer, or answers is fine. That you can use the shorthand with the plus minus, or you can write it out as 2 numbers. Works fine for me. So you see the answer is a little messier here. What do we call a good Lord, complex number, a rational number and an irrational number combined. So let's look at one last one. Again, the problem needs to be set equal to 0, so I'm going to move this 8 over first. So I get x squared minus 7x plus 8 equals 0. And so my a value is 1, my b value is negative 7, and my c value is 8. So x equals, this is another way to do it, is what you set up like kind of a template for all the stuff that's always there, like the negative, plus minus, the square root, the places that drop the values, the 2, and then these spots are always b's, and these spots are always a's, and then the other spot here is always your c value. So b is negative 7, is 1, and C is 8. So again, looking at the front, I have negative 7, so that means I have positive 7. Looking underneath, I have 2 times 1, so it's 2. And then inside the radical, 7 times 7 is 49. And then here, just 1 negative, so minus sign over here. And 4 times 8 is 32. So x equals 7 plus or minus the square root. 49 minus 32 is 17. And over 2. So last time, as we were doing this number here, was not a perfect square, like 17 is not a perfect square. But also, so we were able to sock it out. And so as we look at, try to sock out 17, well, we ran into a problem because 17 is prime. There's nothing for me to, break it up into. And so we can't reduce or rewrite or simplify a square root of 17. It just is what it is. And so we can't do anything else here to reduce this. Say, well, okay, can I reduce the fraction? So you look at this number here and you say, can we take something out of all of these numbers? I'm not looking at this. Well, there's a 1 there, and that's 7, 1, and 2. They don't all have something I can reduce. So it turns out this problem is not reducible at all. There are our 2 answers. So again, you can leave it like that, or you could write it as x equals 7 plus the square root of 17 over 2, and then 7 minus the square root of 17 over 2. There would be your 2 solutions also. Again, either way you want to leave that is fine. So just when you are trying to reduce those things, like something like if you had x equals 5 plus or minus 15 square root of 3 or something like that. If something ended up here all over 5, like this is reducible because those all have 5s in them. It would end up being 1 plus or minus 3 square roots of 3, like when we were done with it. But if I change one little part of that, now if I change the denominator, like if I just think about that, change the denominator there to 6. 5 and 6 don't have anything in common. 5 and 15 and 6 do, but since they don't all have something, I can't rewrite this. I can't just divide this part. So we would just end up leaving that. So all 3 numbers here have to have something in common in order to reduce that. All right. Hopefully that helped, and you guys have the 5-7 worksheet to be working on. So I don't feel like I need to give you any extra problems there. So let me know if you need help.